Hello and welcome to the feedback video for assignment 2 Motion. In this video we're going to be looking at the last question on the assignment, and at the end of the video you'll be asked to complete a question that includes some similar concepts. Please pause the video, attempt the question and hand it in to your teacher as soon as possible. So in this question it was wanting you to calculate the height of an umpire based upon some information given, and it was talking about a coin that had been tossed up before a match. I always think with these sorts of questions it's quite a good thing to draw a diagram. So if you look at my diagram in the bottom corner, as I indicate the path of the coin there, you can see that the path is linear, and that's important for this problem. But also I've included some of the variables, so the 0.6 meters between where the coin was flipped and the top of the umpire's head, and the time given. And in this instance as well, the upward velocity or upward initial velocity of 5.4 meters per second. These are the three that you're given in the question. Now what's important about this problem is not only the linear path of the coin, but once that coin leaves the umpire's hand it is only under the influence of gravity, and therefore we can say that the acceleration of that coin will be downwards and will be the same magnitude that you're given in your test data, which would be 9.8. Now I've labelled it as negative 9.8 as that we've taken the upward direction as being positive. So I've left the initial velocity as a positive 5.4, and because the acceleration of gravity is acting downwards, I'm giving it negative 9.8 meters per second squared. So the first thing that I'm going to write down is just a list of all the variables that I've got for my diagram, and I've also got D there labelled as displacement, which is what I want to calculate as we're looking at the height of the umpire. Now because in my diagram I've labelled all upwards variables as positive and all downwards variables as negative, my final answer for displacement that I get after using a kinematic should be a negative value, as it will be a measurement from a specific point, the point being the umpire's hand, and it will be a downwards measurement towards the ground. Once you've listed your variables and checked that all your directions are correct, the next step is to choose the correct kinematic equation. In this case it would be this equation here. You can see it contains the 3 known variables and the 1 unknown variable that I'm trying to calculate. The next step is to substitute the variables into the equation. When you do that, just take care not to miss off any negatives, and you might also want to bracket everything just to keep it clean when you enter it into your calculator. Now if you type those numbers in, you should get an answer of negative 1.11616 meters. Remember, that's a negative displacement. That's a measurement from the umpire's hand, where he flipped the coin, down to the ground where the coin ended up. Now that's not the end of the question. We wanted to calculate the height of the umpire. So you can see that in my diagram I've now labelled where that displacement would be. Now I've rounded in my diagram. I would suggest when you're doing your calculations you do not do any rounding until the very end. But as you can see from the diagram, it's just a case of adding those two distances together, and you should get a total height for the umpire of 1.71616 meters. Once you've calculated this answer, it's just a case of stating it to the correct degree of accuracy. If you look in the question, the 3 variables that we were given, we've got the time that was given to 3 significant figures, both the initial velocity and the other distance were given to 2 significant figures, and therefore we can only be as accurate as our least accurate piece of data, which was to 2 significant figures. And so our final answer becomes 1.7 meters. Right, if you could pause the video, complete the question and hand it back to your teacher as soon as possible.